Let us proceed to the chemistry of alkynes. Alkynes, the same with alkenes, they contain a functional group of a multiple bond, particularly a triple bond in between two bonded carbons. And out of this, three bonds in between two bonded carbons, one of the bond is a sigma bond, and the other two remaining bonds are what we call the pi bonds. Okay, and mind you that during chemical reactions of organic compounds, multiple bonds, specifically the pi bonds in that multiple bonds, are prone to breaking. Okay, knowing that in between sigma bonds and pi bonds are weaker compared to sigma bonds. Now, talking about the chemistry of alkynes, we will only study two of the most important reactions of alkynes. The first one is the catalytic hydrogenation. No problem with the term itself because you have encountered this type of reaction during the chemistry of alkenes. So the same process, this is just addition of hydrogen. Okay, again, this is just addition of hydrogen in the presence of a metal catalyst. That is catalytic hydrogenation, addition of hydrogen in the presence of catalyst. Usually, a metal catalysts are being utilized. So in the reaction, catalytic hydrogenation of a triple bond, you have an alkyne, any alkyne, in the presence of a hydrogen gas. In the reaction, the first pi bond will break. Again, in the reaction, the first pi bond will break, right? Thus, the intermediate product is an alkene. You will produce an alkene. Again, upon breaking the pi bond, each carbon will now have unpaired electrons to stabilize that. Each of that unstable carbon will be added with this hydrogen electrophile, producing an intermediate product of alkene. This is still an intermediate product because recall that alkenes are also prone to this type of reaction. Alkenes undergo catalytic hydrogenation. Thus, the reaction will proceed. From alkene, it will be further undergo hydrogenation. Thus, another pi bond will break and hydrogen plus will be added as the electrophile to the unstabilized double bond carbons. Again, from alkene, a pi bond will break and it will be stabilized via addition of the hydrogen electrophile, producing the final product, alkane. Again, for catalytic hydrogenation using a strong metal catalyst, if these strong metal catalysts are utilized in the reaction, then the final product would be alkane, a saturated hydrocarbon. Now, to control this reaction, we can actually change the catalyst. If our desired product is only until alkene, we can control the reaction. How? By simply changing the catalyst. Instead of a strong catalyst, we can use a weaker type of catalyst. So we can change the catalyst, for instance, using a Lindlar's catalyst. A Lindlar's catalyst also contains a metal. Particularly, it contains lead. I'm sorry, it's PD. Okay, it contains lead. However, lead alone is a strong metal catalyst. So in a Lindlar's catalyst, the lead metal is being added with other compounds to weaken the activity of the or the strength of the lead metal. It's being added particularly with calcium carbonate and quinoline. Okay. In some other references, a Lindlar's catalyst is described as a poisoned catalyst. Poisoned because this catalyst is being added with other compounds to weaken, not to weaken its catalytic strength. So, in the good example of a catalyst to control this reaction to have a final product only until alkene is to use a Lindlar's catalyst. Okay. So again, during catalytic hydrogenation, addition of hydrogen in the presence of a Lindlar's catalyst, the final product is only until alkene. Okay. The last chemical reaction that we will talk about under alkynes is hydration. Rather, again, it's hydration or simply the addition of water. Okay. Now, this hydration reaction, recall that during hydration, you have encountered this in the chemistry of alkenes. Hydration occurs or proceeds in the presence of an acid catalyst. So the usual symbol for an acid, presence of acid, is simply write H plus a proton, knowing that any acids are proton donor. So a very good example of an acid that can be utilized as a catalyst during hydration is the sulfuric acid. And for alkynes, hydration using a sulfuric acid catalyst is also facilitated by another catalyst, which is a mercuric sulfate. Again, aside from sulfuric acid, aside from sulfuric acid, another catalyst, okay, that is being utilized during hydration of alkynes, addition of water of alkynes, is the mercuric sulfate. Okay, so again, um, for hydration, addition of water. Now, what are the electrophiles that will be produced? Okay, what are the electrophiles that will be produced out of the added reagents? Okay, this would be the reagents. The question here is, what are the electrophiles that will be produced actively using these reagents during hydration reaction of alkynes? The following electrophiles that will be produced are H plus coming from the acid, sulfuric acid, and the OH, okay, coming from the water. Okay. Again, these are the electrophiles that will be produced, that will be added upon breaking one pi bond from alkynes. The hydrogen plus coming from the sulfuric acid and the OH coming from the water. Now, what would be the manner of addition? It follows Markovnikov's rule. The same idea that you have learned under reaction of alkenes. Recall that hydration of alkenes follows Markovnikov's rule. Markovnikov's rule. Markovnikov's rule, life hack in order for you to easily recall the idea of Markovnikov's rule is that the hydrogen, okay, this hydrogen will always be added to the carbon with greater number of hydrogen substituents. Okay. Again, it will be added to the carbon, okay, with greater number of hydrogen substituents. That would be the life hack for you to easily recall Markovnikov's rule. Simply memorize where does hydrogen will be added. Okay. So initially, during hydration of alkynes, you have any alkynes, okay, any compounds of alkynes, a carbon to carbon triple bond functional group. Upon the addition of water, since this is hydration, make sure that the reagent contains an acid. Usually, this is in a form of sulfuric acid. Okay, this is to have a donor of hydrogen. Okay, then this is facilitated also by a catalyst mercuric sulfate. So again, what are these um, electrophiles that will be produced out of these reagents? We have the OH coming from the water and the H plus being donated by the sulfuric acid. So in the reaction, a pi bond again will break. Okay, so the first pi bond will break. Therefore, each carbonyl, okay, will be unstabilized. Okay, to make it stable, addition of these electrophile OH and the hydrogen will be added to each carbon. Okay, so I'll just write it here. You have a carbon double bond. Each has an R group. Each has an R group. So this time, the question is, where does OH will be added? Where does hydrogen will be added? So just take note, the carbon with the greater number of hydrogen, that will be the um, addition site of the hydrogen. So let's say this carbon uh, contains the highest number of hydrogen substituents. So this is where the hydrogen will be added. And for this carbon with lesser hydrogen substituents, this is where OH will be added. So this would be the initial uh, product, no, intermediate product during hydration reaction of alkynes. This is not yet the final product. So as you observed, what are the functional groups present in the initial or intermediate product? You have a double bond, meaning an alkene, and you have an OH, meaning that functional group belongs to alcohol, making it an enol. Again, the intermediate product for hydration of alkynes, the intermediate product is enol, not yet the final product. Why is it that enol is not yet the final product? It is because enol is very prone to tautomerization. If you still recall the term tautomerization, okay, tautomerization. It's tautomer, it's letter O, rization. All right. Again, enol quickly tautomerizes into its ketone form. I have discussed this term during our discussion on isomerism. Tautomerization is being observed in between enol and a ketone form. So again, enol will proceed. Okay, the reaction will proceed from alkynes producing enol. The reaction will proceed until forming the final product. Okay, so again, a pi bond is prone to breaking. Okay, so this pi bond, one last pi bond will break. Okay, so this time carbon each carbon will have one unpaired electron. Each carbon will have one unpaired electron upon breaking the pi bond. So to stabilize each carbon, this this oxygen here will be deprotonated. Okay, it will be deprotonated, meaning when you say deprotonated, the proton part will be removed, meaning there will be removal of this hydrogen. Okay. Now, where will that hydrogen be added in order to stabilize these carbons? Of course, Markovnikov's rule, this hydrogen will be further added to the carbon with a greater number of hydrogen. Okay. So from this um, skeletal um, structure, you'll have this carbon being stabilized via further addition of the hydrogen from the protonation process of this part of enol. All right. While this unpaired, recall, we still have an unpaired electron for another carbon. Okay. Again, this carbon is not yet stabilized. Okay, so for this unpaired electron of the other carbon, it will form a bond towards oxygen. It will form a bond towards this oxygen. All right. And that will make a stable form of the whole structure. You can see each carbon already now have the total number or total stable number of bonds. Each carbon has 4 bonds. Each carbon here has 4 bonds. So these are all stable already. The whole structure is stable, producing a ketone. Diba? This is a ketone. Ketone is RCOR. And that is being represented by this product. So please take note. Hydration reaction of alkynes. Hydration reaction of alkynes. The final product is a ketone. Okay. And as you observed here, enol-keto forms, they are said to be tautomers with each other. Okay. They are in chemical equilibrium actually. Okay. They are in chemical equilibrium to each other. Okay, tautomerism, that actually qualifies isomerism, if you can still recall. Tautomerism, I have mentioned this during isomerism. This is particularly a type of constitutional isomerism or structural isomerism. And how do we define a constitutional or structural isomerism? Remember that when we say constitutional isomerism, meaning it refers to an existence of a compound with the same formula. No, the same formula, but they differ in the structure. Particularly, they differ due to the order of bonding. They differ to the order of bonding. Okay. Again, constitutional isomerism, the same formula but different structure. Why they differ in structure? They differ particularly to the order of bonding. And that is very observable to enol-ketone forms. No? During tautomerism, you can see here the interconversion of the two form, which involves the movement, diba? Movement of this hydrogen, okay, from here to this carbon. Okay. And the reorganization. There is reorganization of the double bond, diba? From here, the double bond here, okay, to the double bond in between carbon to oxygen. So, andito na yung double bond. So, again, there is interconversion, no? There is differences in the order of bonding. That is why it qualifies constitutional structural isomerism at the same time, the tautomerism. Okay, there is interconversion, the movement of hydrogen atom upon deprotonation, okay, deprotonation, and the reorganization of bonding electron from a double bond between carbon to carbon and the double bond to between carbon to oxygen. Okay, so in your notes, you'll see this reaction. It's just the same. Okay, that one. Okay, the same lang to akong i-discuss earlier in this representation. Alright, now what is the specific example? Let's have propine as a specific alkyne. As you can see here, propine has a carbon to carbon triple bond. So in the reaction, hydration, first pi bond will break. First pi bond will break. So each carbon here will now have unpaired electron. To stabilize each carbon, you'll have the electrophiles OH and the H plus. That will be added to each carbon. So recall Markovnikov's rule, the hydrogen will be added to the carbon with greater number of hydrogen. So for this carbon, it has no more hydrogen. Okay. While for this carbon, it has still one hydrogen. So the hydrogen um, attachment will go to the second carbon. Okay. As you can see here. So the OH is being added to the second hydrogen. This would be the first carbon, second carbon, and the third carbon. Okay. Again, upon breaking the pi bond, addition of hydrogen, the H plus goes to the carbon with a greater number of hydrogen substituents. So hydrogen will go to the first carbon on the second carbon, having the multiple bond where triple bond is present. It will be stabilized via addition of the OH. From an enol, from this enol, the reaction will proceed, okay, producing a ketone. So there will be interconversion of the two form. There will be movement, no? Movement of this hydrogen due to deprotonation. Okay, movement of hydrogen going to, okay, this first carbon, making it that ECH3, and reorganization of the bonding electron from this carbon to carbon double bond. This time the double bond is between a carbon and oxygen. Okay, so again, an enol in a keto form, they are tautomers to each other. So that is all about hydration reaction. So let's try the following example. For instance, you have this alkyne added with water in the presence of these catalysts. You will now have the products ketone. Okay, so the final product would be a ketone. So how do we write the ketone product? So before the ketone, para mas maintindihan, I will write first the enol, intermediate product. So you have a double bond na lang. This carbon here will now be added with the hydrogen, and this carbon will be added with the OH. Then the reaction will proceed forming a ketone form. Okay, so from this, I'll just write it down here. So you have so this will be the ketone form. A carbon and ayan. So a carbon with a double bond towards oxygen. This is a ketone. Okay, so this would be the ketone product. Next example, you have hydrogenation. Okay, so for hydrogenation, skeletal, given that skeletal structure, we simply remove one of the pi bond. Okay, since Lindlar's catalyst is being utilized in the reaction, Lindlar's catalyst, the final product is only until alkene. Okay, again, the final product is only until alkene. Next, another hydration, no? Hydration reaction. So for this example, you have this triple bond, triple bond. So the first pi bond will break, giving this enol product. So you will now have, okay, then the OH, okay, following Markovnikov's rule. All right. Again, the hydrogen here is just imaginary. Okay, for skeletal structure. The hydrogen is actually added in this carbon. Okay. Then the final product producing a ketone will look like this. So you have mm, hmm, mhm. So for its ketone product, you'll have this 1, 2, 3, 4, 5. Okay. So I'll just write it in this way. All right. It's just the same. Diba? You have how many carbons? 1, 2, 3, 4, and 5. It's just the same. This is carbon 1, carbon 1, carbon 2, carbon 3, 4, and carbon 5. All right. We're in at carbon 2. This will be the part that will give the carbon double bond towards oxygen. And for this carbon, this is where further hydrogen is being added. Okay, upon deprotonation of this oxygen, this hydrogen will be added to this carbon where the most hydrogen substituents are present. All right. And finally, for this example, hydrogenation in the presence of a strong metal catalyst. So we simply write 1, 2, 3, 4, 5 pentane. 1, 2, 3, 4, 5. All right. So you will have an alkane as the final product in a form of in the name of pentane. This presentation, your main goal is to learn how to identify if a ring compound, if a cyclic compound is aromatic or not, when it is aromatic, when it is not aromatic. Okay? Now, when deciding if the compound is aromatic, we go through the following conditions. Okay? So, natin mga criteria. So if the compound does not meet all of the following criteria, it is obviously not likely aromatic. So the following, ayan, are the considerations no na dapat ninyo put into in your mind. Okay? So una, ang molecule must be cyclic. Okay? Of course, dapat ring of atoms ang inyuhang ma-encounter for it to be aromatic. Walay aromatic nga open chain. We're talking here a ring of atoms. So it has to be cyclic. That's number one. Second, the molecule must be planar. Okay? So ibig sabihin, all atoms in the molecule will lie on the same plane. Okay? Now, this consideration is usually met by homocyclic nga mga compounds. When we say homocyclic, homo, di ba pag sinabing homo, uniform. So, dapat ang atong makita sa ring, puro the same or identical atoms. Let's say, for example, ayan, in a benzene ring, di ba puros na siya carbon bonded together in a cyclic manner. Homo, cyclic ring na siya. Pag makakita ka og, nga ni example, you have a 5-carbon ring, but aside from carbon, inside a ring, being connected together, there is another electronegative atom. Example, nitrogen. That is not anymore homocyclic, no? That is heterocyclic. Kasi naanay other electronegative atom present inside the ring. So usually, ang planar characteristic ng isang aromatic ring, this consideration is usually met ng mga homocyclic compound. Okay, so pag planar, mura siya ka ng katong geometry nga trigonal planar. Okay? Or naka-trigonal planar siya. Mura siya nasa plane. Okay? Next, the molecule is fully conjugated dapat. A conjugated double bond system. Okay? Take note ha, conjugated. Yung double bond must be alternating. Kumbaga. Or, dili gid necessary nga ga-alternate ang double bond. Pwede din, ang molecule could also be conjugated if every atom in the ring has a p orbital. So, ito yung mga consideration nato for it to be conjugated. For it to be fully conjugated. Dapat every atom in the ring has a p orbital. Okay? Or, all atoms, as stated in number 3, all atoms are sp2. Ayan, sp2 hybridized. Okay? It's actually the same yung thought, no? Kung sp3 hybridized, automatic na ay isa pa ka p orbital nga free, empty. Di ba tulo man ka p orbital? Tulo ka p orbital. If you recall, tatlo yung p orbital. Kasi each orbital ng p will occupy 2 electrons. So total of 2, 4, 6 electrons kapag p orbital. Di ba p6 hanggang p6. So kapag sp2, dalawa lang yung p orbital dyan. So isa pa ka p orbital nga empty. Nga pwede mag-reside dito ang electrons. So, the same lang gihapon na siya ang consideration 1 and 2 for number 3. Okay? Now, how do we determine if ang atoms are sp2 hybridized? Okay, how do we determine? Kasi sabi dito, dapat all atoms in a ring is in a sp2 hybridized. So, take note ninyo. Dali na lang ako ibutang. Okay? So, take note. Yan. To determine. Okay? In order for you to determine if atoms are sp2 hybridized, you have to check the following. Okay? You have to check if, una, all carbon has a double bond. All carbon has a double bond. So, pwede ka na siya, considered na siya as sp2 hybridized. If lahat ng carbons in a ring, it carries a double bond. Okay? So, nag-alternating, kumbaga, ang double bond in that ring, then each of that atoms are considered sp2 hybridized. Okay? Or, sp2 hybridized din ang atom if an atom has one or more lone pairs. Okay? And that atom is attached to an sp2 hybridized atom. I repeat, sp2 hybridized din ang isang atom if an atom carries one or more lone electron pairs, and that atom carrying a lone pair is attached to an sp2 hybridized atom. Say, for example, you have this ring, a 5-membered ring. Okay? Diba? This is a 5-membered ring. And for carbon 1, let's say this is carbon 1. Example lang ha, hypothetical. Although that is not carbon 1. Okay? Let's say this carbon labeled as carbon 1 carries lone pair. Okay? So ako siyang in-circle kani. Diba? That is a lone pair, isang lone pair. Sabi sa criteria number 2, pwede sp2 hybridize ang atom if it carries a pair of lone electrons. Okay? Kahit wala siyang double bond attached to it, diba? This is a carbon. Wala may double bond gayang gina-carry. Single bond man ni, single bond, imaginary, isa ka hydrogen kasi skeletal man ni siya. Diba? What surrounds, diba octet rule ang gina-follow sa carbon. So, dapat 8 surrounding electron. So, 2, 4, 6 man na inyong kakakita. Duha ka lone electron, duha ka bonds. Okay, duha ka bonds, that's equivalent to 4 electrons, plus 2 electron ng lone electron, 6 na siya. Imaginary yung hydrogen. So, 8 lahat din yan. Okay? So, walay double bond na gina-carry ka na nga carbon labeled as carbon 1. But, pasok siya sa criteria nga number 2. An atom carrying a lone pair and it is attached to an sp2 hybridized atom. Man ni siya directly attached. Diba this is attached to this carbon? Question, that carbon ba is, question, this carbon ba is an sp2 hybridized? Itong carbon din ba dito is an sp2 hybridized? Obviously, yes. Diba? Ang atong timailhan kapag sp2 hybridized, diba, ako nang i-share sa inyo ang technique. Ang sp2 hybridized carrying a double, ayan. If it carries a double bond, okay, if it carries one double bond, that is sp2. Okay, that is sp2 hybridized. If it carries one double bond. So yung atom na to na siya double bond, yung atom na to meron siyang double bond. If a carbon has a double bond, sp2 hybridize siya. Now, nagkataon na itong carbon na to labeled yung kulay pula. Yung kulay pula na carbon, highlighted, wala siyang double bond. Pero, it carries a lone pair and is attached to an sp2 hybridized. Then, it can be considered sp2 hybridized. Meaning, meron siyang isang p orbital dyan kung saan nagre-reside doon yung lone electron pairs niya. Okay? So, that is how to identify if an atom in a ring is sp2 hybridized. Kasi kailangan yan in order for you to determine if aromatic or not. Okay? Kasi nga, kailangan na ang atoms sp2 hybridized, that is one criteria. Dili man pwede nga, ako na siyang, please screenshot ninyo ha, screenshot ninyo, kaya ako na siyang i-erase. Okay. Now, dili pwede nga, ang isa lang iyahang ma-check sa list of consideration. The rest, wala niya na-attain ang planar, conjugated, ang Huckel's rule. No. Dapat ito lahat apat makita, no? Makita nato sa mismong ring for it to be aromatic. Okay? And the best way to identify, okay, if aromatic yung ring is to compute if it follows Huckel's rule. Okay? This is applicable to both homocyclic ring and heterocyclic ring. Okay, so unsa maning Huckel's rule? Okay, Huckel's rule, ito yung formula niya, 4n plus 2. Okay, ayan, number of pi electrons, diba? This is pi, symbol sa pi electrons. Number of pi electrons equals 4n plus 2. So dapat, it follows Huckel's rule if ang imong makuha nga n value kani, ang imong makuha nga unknown n value is any positive integer. Okay? Any positive integer. It could actually be 0 or any positive integer. Basta as long as walay fraction, decimal points. Walay fraction, walay decimal points. That does not follow Huckel's rule. Okay? Now, sa ring, I have mentioned already, di ba, unsa ang pi bonds. Sa, let's say for example, you have a multiple bond, a carbon to carbon, multiple bond. Yung isa dyan, sigma bond. Yung remaining is a pi bond. Always ang isa dyan, sigma, the remaining pi bonds. So kapag triple bonds, isa pi bond, dalawa, isa sigma bond, dalawa dyan is pi bonds. Okay? Now, ang sabi dito, pi electrons man. Pi electrons. We're talking about electrons. Ibig sabihin, sa isang pi bond, that consists of 2 pi electrons. Nakuha ba? Sa isang pi bond. Kasi sa isang bond, dalawang electrons man yan, di ba? Sa isang bond, dalawa yung electrons. Okay? So, again, sa isang pi bond, dalawa ang pi electrons. Okay? Now, let's try. No, let's try to determine if ang ring is aromatic or not. Let's start with homocyclic. No, homocyclic rings. So, obviously, benzene. Applying lang niya siya ha, applying Huckel's rule agad. Okay, applying Huckel's rule. Ayan. So, we have benzene. Now, ang benzene, if you are asked to determine the number of pi electrons sa benzene, obvious man kaayo. Kasi yung pangalawang bond, di ba, na may alternating double bonds. Kaning mga pangalawang bonds, these are pi bonds. Diba? These are pi bonds. The rest, yung mga unang bonds, sigma bonds yun. Meaning nabuo yung bond na yun via end-to-end collision. Basta sinabing pi bond, if you recall your notes, ang pi bond that is formed when p orbital overlaps sideways. Okay, pi bonds, p orbital yung nag-o-overlap. Alright? Sige, let us try to determine the number of pi bonds sa benzene. The benzene, it has 3 pi bonds. Ang applicable sa Huckel's rule, di ba? Huckel's rule is number of pi electrons. Electrons equals 4n plus 2. Ang atong pangitaon is ang n. Ang atong pangitaon is n. Okay, question. Ilan yung number of pi bonds sa benzene? Pi electrons pala. Ilan yung pi electrons sa benzene? Electrons. Electrons. Okay, very good. There are 6, no? There are 6 pi electrons. Take note ha, sa Huckel's rule, electrons, hindi yung bond. Okay, pi electrons, dumdumi, pi electrons. Sa isang bond, 2 yung electrons. Yan yung tandaan nyo. And basic man na siya, kabaluman mo ana, no? So, kung ato i-substitute, we have 6 equals 4n plus 2. So, sa algebra, di ba, transpose rin siya. Okay? So, say for instance, ato i-transpose 6 minus 2, 4n. Sige, tell me what is n. It is, n is equals to, sige, atong tagsa-tagsaon ha. Yes, n is equals to 1. Sige, atong yung tagsa-tagsaon para magsabihin, 6 minus 2 is 4. Okay? So, 4n. So, ito i-simplify, divide 4, so 1 yung n. Okay? N is equals to 1. Okay, therefore, is n a positive integer? Is it? Obviously, it is a whole number, so check. It follows Huckel's rule. Obviously, benzene is aromatic. Naphthalene, what about naphthalene? Check natin if it follows Huckel's rule. Tell me, how many pi electrons sa naphthalene? Madali lang kapag homocyclic kasi diretso katong pangalawang bond sa double bond, yun na yun, yung pi electrons. Kung nanagay mga lone pair, dito na ta maglibog slight. Yes, very good. There are 10, no? 10 pi electrons. Okay, so 4n plus 2. Sige, tell me, what is n? Diretso na, pwede ra matahon. N is equals to, very good. N is equals to 2. So, correct. It follows Huckel's rule, so aromatic siya. Very good. What about anthracene? Tell me how many pi electrons? Electrons, how many pi electrons? Very good. 14. No? So, 14 equals 4n plus 2. Tell me n. Tell me the unknown n. Determine n. It is 3. Very good. No? So, that is how to determine. No? If yung ring follows Huckel's rule, you use 4n plus 2 rule. Or that is also known as Huckel's rule. Ngayon, let's try to have Huckel's rule. Before tayo mag-proceed sa pag-determine if it follows Huckel's rule for heterocyclic ring, homocyclic ring, pero merong lone pair. Okay? Heterocyclic ring, pero merong lone pair. So, no problem. Ito yung binigay ko kanina, di ba? Yung pasok ito sa criteria nga number 1, 2, 3. Number 1, 2, 3 nga consideration sa aromaticity. Kasi, di ba dapat may all are sp2, hybridized, no? So, for this example, this is actually in this carbon 1, meron siyang free nga empty nga p orbital. So ako na siyang na-discuss kanina, di ba? Yung atom na to carries a lone pair and it is attached to an sp2 hybridized atom. So diretso na ta sa pagkuha sa Huckel's pag-determine if it follows Huckel's rule. Okay. So unsaon nato pag consider if ang lone pair is part of the pi electrons. If that lone pair resides to the p orbital. Sige. So take note, if mo siya inyo i-take note, basta makakita gani mo og lone pair. Okay? Lantawa dayon na nga atom. Okay? Lantawa na siya na atom. Now, dili siya if, no? For sp3 hybridized. Okay? sp3 hybridized atom, okay, carrying lone pairs. Okay? Carrying lone pairs plus has no double bond. So akong ginamin is kaning carbon 1, di ba? sp3 hybridized atom siya. Okay? sp3 hybridized atom siya carrying a lone pair. Okay? It carries a lone pair and has no double bond. Okay? So take note, in determining pi electrons, only one pair of lone electrons, lone electrons counts as pi electrons. So, ibig sabihin, kapag naka-sp3 hybridized, by the way, kanina pasok siya sa fully conjugated kaning number 1 kasi na siya isa ka empty nga p orbital. Okay? Kasi di ba isa ka consideration, every atom in the ring must have a p orbital. Okay? So kana siya pasok kasi meron siyang p orbital. Okay? Now, considering this carbon, naka-sp3 hybridized siya. So ako siyang i-magnify ha. This is the carbon nga naa siya'y lone pair, bonded siya to a carbon nga sp2 hybridized. Na siya'y imaginary hydrogen. Kung imong i-count ang iyahang electron groups, that is 1, 2, 3, and 4 electron groups. Diba pag 4 electron groups, kung ipa-identify mo og shape, that is tetrahedral. Kapag tetrahedral, sp3. Diba kapag tetrahedral, ang hybridization ng central atom na yan is sp3. Kapag 4 na electron groups that surrounds that atom, sp3 hybridized yan. So ano lang, para madali mo. So, sp3 hybridized yung atom na yan. Does it carry a lone pair? Yes. Okay. So for sp3 hybridized atom carrying a lone pair and has no double bond, wala siyang double bond, take note, only one pair of lone electron will be counted as pi electron, meaning yung one pair of lone electrons niya is being donated to the ring. Okay? Which contributes to the stability ng electron delocalization ng ring or ng aromaticity ng mismong ring. Okay? So, kung ipa-identify mo sa number of pi electrons, there are about 6 pi electrons here. Okay? For that ring. Kasi aside from this, double bond, this is already 4. pasok man siya sa criteria. Okay? Nga kapag ang atom carrying sp3 hybridized, take note ha, kapag ang atom sp3, not sp2. Kapag ang atom sp3 hybridized, carrying a lone pair, has no double bond, isang pair lang ng lone electron will be counted as pi electrons. Okay? So that is counted, yung one pair na yan. What if, so ako siya versus, what if yung structure is ganito? Instead of imaginary hydrogen, that is also a lone pair. Let's have, hiwi siya, no? So yung nga ni, this is still sp3 hybridized. 4 surrounding electron groups. Okay, so sp, tetrahedral na siyang orientation. So sp3, kapag tetrahedral, sp3, hybridized. Carrying a lone pair, yes. Walang double bond, yes. But take note, only one pair of lone electron will be counted as pi electron. Ibig sabihin, yung part lang, okay, ng ring that contributes to the electron delocalization or stability ng ring is isang pair lang. Okay, therefore, 6 lang din yung pi electrons dito. I hope nakuha ninyo ha ang meaning ani. Question. Sige, pag-question mo. Nasabtan? Pag-type in daw mo, nasabtan ra, yes or no? You have to know how to determine if it is sp2, sp3. Kahit yan lang, sp2 or sp3. sp2 or sp3. Okay, you know already the hints kapag sp2. sp2 carrying a double bond. sp3, 4 electron groups that surrounds that central atom. So naka-tetrahedral shape. Then that is sp3 hybridized. Okay? Now, if naka sp2 hybridized yung atom carrying a lone pair, example ha, i-draw na ako. Say for instance, yung pyridine ring. Ayan. So this is actually heterocyclic already. Okay. If ever you encounter an sp2 hybridized atom carrying a lone pair, okay? Carrying a lone pair, plus meron siyang double bond. Take note, that atom, okay, is actually using its p orbital for the electrons in the double bond. Ibig sabihin, yung pi electrons that contributes to the stability of the ring is yung pi electrons na nasa, ayan, na nasa pi bond. Hindi yung lone electrons. Okay? So, i-dictate lang na ako ha. I-dictate na ako. For sp2 hybridized atom, carrying a lone pair, but has a double bond. Carrying a lone pair, but has a double bond. Then, yung pair of electron, that pair of lone electrons, that pair of lone electron will not be counted. Will not be counted as pi electrons. So, yun yung dalawang i-consider nyo in determining Huckel's rule. Those are very important. Dalawa lang yun, dalawang sentences. Okay? Kani ang first, o katong second na akong dimension, wala namang gid space. Okay? So, ulitin ko ha. Paglantaw nimo sa ring, kita ka og lone pairs. Automatic, i-apply ni siya kaning number 1 ug katong akong gi-mention, gi-state ganina number 2 nga statement. Again, kung makakita ka og ring, then naay lone pair of electrons, i-apply dayon ni siya. I-check nimo kung kanang atom sp3 hybridized atom carrying a lone pair, has no double bond, then upon counting the pi electrons, only one pair, okay, only one pair ng lone electrons will be counted as pi electrons. Kailangan ba ang pi electrons to determine the Huckel's rule? Kung ga-follow ba siya Huckel's rule? Yes. That's why kailangan yun nimo siya sabton kaning duha ka statement. Okay? Kaya it has something to do with the pi electrons. Kailangan nimo i-determine di ba ang pi electrons para makuha ni nimong n. Para ma-determine nimo oy kung ni-follow ni siya sa Huckel's rule. Then kung tong second statement, if you found out nga okay, sp2 siya. Okay, sp2 hybridize siya. sp2 again, naa siya double bond. Muna siya ang pinaka the best hint nga inyuhang i-consider kung sp2, no? sp2 hybridized ang atom. Okay, naa siya double bond, isa ka buok. Automatic sp2 na siya, sp2 hybridized. Okay, so for sp2 hybridized atom plus carrying a lone pair, okay, so na siya double bond, then that lone pair will not be counted as pi electrons. Asa ang pi electrons ato? Katong double bond, katong second bond sa multiple bond nga iyang ginakarry, yun yung pi electrons. Okay? Yung lone pair, hindi. Okay? That is, this resides sa sp2 orbital, hindi sa pi electrons. Sige. Try na to. I-check to ang ito. If this structure follows Huckel's rule. Okay? So, obviously, it has 6. No? 6 pi electrons. This is part of pi electrons. Kakasabi lang, di ba, sa first statement, isa siyang sp3 hybridized atom carrying a lone pair. Walang double bond. So, counted ang lone pair as part of pi electrons. So, 6. Automatic, di ba, pag 6 electrons, n is equals to 1. This one, 6 lang din, yung pi electrons. Ito lang yung pi electrons, part ng pi bonds, tatlong pi bonds. Kasi nga, this is an sp2 hybridized atom. So, sp2 hybridized atom, carrying a lone pair, yung lone pair niya will not be counted as pi electron. Ito yung counted as pi electrons, kaning second bond. Okay? So, pasok. All of this follows Huckel's rule. Okay? Sige. Let's try the following. Akong ansiran is number 1. Okay, let's have number 2. 3, 12, 3, 5. Then the remaining, I will transfer it in a Google form para assignment 4. Okay, so 1, 2, 3, 4. 1, 2, 3, 4. Okay. So let's have 4 and sige. Ito na lang. Okay, so the rest, ay, nasubra na, no? 1, 2, 3, 4, 5, 6, 7. 1. So, ang inyong ansiran is 1, 2, 3, 4, 5. Okay, para 2 points each. So, 10 pattern. By the way, katutanan assignments will be recorded as quiz. So, you make sure nga inyo yung tarungunog answer inyo assignment. Kung na siya, chance na gina ninyo para makabawi. Okay? So, before mo mag-submit, tarong nga gid ninyo answer. Assignment ba siya? So, taas ang time ninyo to answer. Okay. Sige. So, I'll start with number 1. I will identify if the following molecule is aromatic or not. Yung best way to determine is diretso na ta sa Huckel's rule. Okay? Ay, sorry. Dali lang. Nalock. Ay. Sige. So, let's have number 1. Okay, naglag pa man. Okay, ayan. So, number 1, diretso ko ha sa Huckel's rule. So, ingon ko sa inyo ha, kung makakita kayo mong lone pair, diretso din to i-apply ang 2 statement. Asa siya pasok dito. Kung wala siya dito, then that is not aromatic. Okay? So, number 1, let me identify ha if this nitrogen is in sp2 or sp3. So, obviously, this is sp. Sige, tell me daw, be. Tell me the nitrogen there. Nitrogen na siya'y hydrogen bonded, single bonds duha, then lone pair. 4 na electron groups. Tell me if is it sp2 or sp3? Very good. sp3. Now, unsa to atong criteria para ma-consider ang pi electrons? If sp3 hybridized, carrying a lone pair, it has no double bond, 1 pair only. Diba? Only 1 lone pair will be counted as pi electrons. So, how many pi electrons? 6. Therefore, is it aromatic or not? Tell me, is it aromatic or not? Okay, very good. No? It is aromatic. Okay? So, based on Huckel's rule. Based on Huckel's rule, this is aromatic. Okay, number 2. How many pi electrons? Obviously, there are. Sige, type in. How many? 4. Okay? So, kapag 4, do you think aromatic or not? Try to compute. Try to compute. 4n plus 2. Kapag 4, do you think whole number inyuhang makuha? Yes, not aromatic. So, not. So, ana lang. Not aromatic. Okay, number 3. O, kani diretso. Kung na makita nga lone pairs, kato da yung dalawang statement. Okay, apply da yung dalawang statement na ay lone pair. Okay. Is it sp2, sp3? Tell me, sp2, sp3 ang nitrogen. Never mind the charges ha. Kung ano na siya, ibig sabihin kapag negatively charged, nag-gain siya, positively charged, nag-lose siya ng electron pair. Yes, very good, sp3. So, sp3 plus it carries a lone pair, then wala siyang double bond. Therefore, 1 pair lang. 1 lone pair will be counted as pi electrons. So, how many pi electrons all in all? 6. So, tell me, it is aromatic or not kapag 6 ang pi electrons? Okay, aromatic. Very good. Pwede na ninyo dili i-compute, no? Kapag 6, kay inyohang basihan kay si benzene. Di ba si benzene kay 6? Benzene ring 6 ang iyahang pi electrons. Automatic na siya, aromatic na siya basta 6 ang iyahang pi electrons. Okay, number 4. Yung electrons, pi electrons niya is only 4 here. Kasi, yung carbon dito, di ba, wala man kayo makita nga lone pair. So, wala kayo makount nga pi electrons dira. Di ba? So, obviously, there are 4 pi electrons here. So, automatic, this is not aromatic. Not aromatic. Kasi di ba this is sp3. Imaginary ang hydrogen. Imaginary ang hydrogen. Obviously, puro single bonds, 4 na single bonds, sp3. Daw, wala man siya ga-carry og lone pairs. Di ba ang lone pairs ang atong i-consider as pi electrons. So, wala man. So, not aromatic. What about this one? Oxygen dito, is it sp2 or sp3? Very good. No, very good. sp2. Kapag yung atom carries 1 double bond, automatic sp2. Kapag ang atom carries 1 double bond, sp2. So, unsa tong statement, kapag sp2 hybridized, if it carries a lone pair, that will not be counted as pi electrons. Yung pi electrons is ito, kaning double bond. So, automatic 6, di ba? Total of 6 pi electrons. So, this is aromatic. And obviously, number 10 is not aromatic. This is just cyclobutane. Diba? Cyclobutane. Wala kay double bond nga makita. Diba? At least na ay alternating double bond. Wa man kay double bond. Puro man na siya single bond. Okay? Wala po siya pi electrons. Okay? Wala siya pi electrons. And number 12, tell me if it is sp2 or sp3 ang sulfur. Very good, sp3. So, total of 6 pi electrons. So, tell me if it is aromatic or not. 6 pi electrons, aromatic or not. Very good. Aromatic. So,